Okay, these next ones look much different. So I'll talk through how this is happening, what's happening here. We have a cosine and we have an arc cosine. They're inverses of each other. And so what should happen is these should just cancel out. That might happen, might not. So we got to look at some real serious details here, probably the most complex thing maybe of the entire year to notice all the details. So arc cosine of 0.7. What that means is if that's the arc cosine, that means you're not plugging in the angle like a typical cosine, you're plugging in the ratio. And so is it possible for cosine to have a ratio of 0.7? Would that fit between here? Yes, it does. If this ratio fits, then the answer here is they simply will just cancel out the cosine and the arc cosine, giving an answer of 0.7. Well, that seems easy. Okay, well, let's keep going. So number 5, sine, inverse, and sine. They should just cancel out. Let's see if they do. So right here we have sine of pi. So since this is just a regular sine, that means you're inputting the angle. So sine of pi, does pi fit in between this value here? No, it does not. Pi is not in here. Now that might sometimes in some problems mean there's no solution, but not in this case. Instead, what I'm gonna have to do is find the sine of pi. So forget the inverse for a second. What is the sine of pi? You could look at the unit circle, if you don't know it in your head. Sine of pi, the y-coordinate is 0. So this value in here, sine of pi, is 0. Now let's find the inverse of sine, the function of 0. So now what this is this now is the ratio. So what angle would give us 0? Well, if I look on the unit circle, there's another value that was also 0. Not that one, we can't use that one, but we could use this one over here, and the answer would be 0 radians. When the sine of 0 would be 0 radians. So the answer here is 0. Is that radian, is that possible as to fit in our restrictions? Is 0 between here and here? 0 is, and so that is the correct answer. Okay, next one. There is a cosine inverse of negative 1.2. That means this, we're plugging in the ratio. So is it possible for a ratio of cosine to equal a negative 1.2? No, negative 1.2, it does not fit here. And there's no way that that ratio could ever exist, because as a ratio, that would be like this, negative 1 to 1.2. Oh, sorry, no, not even. It would be like, the adjacent would be like 1.2 over 1. That would mean the adjacent is bigger than the hypotenuse. That would not ever be possible. So this one would be no solution. So there's 3 different cases here of what could happen. One is where everything just works out. If the ratio fits, that's the answer. If the angle doesn't fit, we find a different angle. Instead of pi, the angle was 0. That would work and fit in the answer. Or if there's a case where the ratio does not fit, there's no way you would ever have a ratio of that, then the answer is no solution.